Hello, I'm Lucy Farron, ZZT, and I'm here to talk about my new 100-day project for 2022. A 100-day project is an online art project where you complete something each day for 100 days. So it's quite self-explanatory. It's global, anyone can join, and I've been doing it for a few years now. And my last one, this was done actually in 2020, and this is just a print actually of the one I did in 2020. I didn't do it last year. I'm just going to hold it up a little bit so you can see it's made of 100 bijou tiles, and it's called 100 Days of Gratitude. For each day there's a different gratitude, and it also includes all of the official Tangle tangles from Tangle HQ that were published at the time. There are a few more now, but yes, that was back in 2020. I did that during lockdown, in fact. So that's not what I'm doing this year. So I'm here to introduce my project for this year, and again, it's going to be a 100 bijou or more than 100 bijou project. So for each day, I'm going to do one or more bijou tiles, and I'm going to be joining them all together, just like this. This, as I say, this is a print because the real thing is up on my wall. It's too big to get under the camera. But this was put together a day at a time, a bijou at a time, over 100 days. So that's the plan for this year as well, to do a little bijou, one or two, each day, and join them together in a certain design. I will need to do more than one each day because I'm actually going to attempt to do all the official tangles on bijous, and the idea is they get put together into a periodic table of tangles. Now, what's the periodic table? Well, here is a periodic table, and this is a periodic table of elements. This is the first and original periodic table, and it's all the elements that exist in the world. Some of them are naturally found in the earth or around us, and some of them are actually produced in nuclear reactions. But there's 118, there is on here anyway, 118, I believe. Yes, I think they've discovered a few more since then, but I thought it's a really nice visual representation of the elements, and I'm going to do my own version with tangles. Bijous are perfect for creating these little squares in the periodic table, and I'm going to have fun deciding just where each tangle will go into my periodic table of tangles. So why the periodic table, and why am I doing this anyway? So I'm really quite interested in classification of tangles. And there's been some stuff done on classification of tangles. I think it was Project Pack 12, where Rick and Maria and Molly and Martha were looking at different types of tangles. And yes, there was a whole project pack on it. So this is my take on the classification of tangles. And sometimes HQ refer to it as zentomology, which is like entomology, like the classification of beetles, or I think it's beetles or insects. But that would be like a family tree type structure, which gives each tangle a unique spot. So that's why I like this format instead. Firstly, it's very visual, very compact, but also there are different categories on here. There are different classifications. So you can see we've got the colours, so that's the families. So different elements fall into different families depending on their characteristics. Also, we've got the columns. Now the columns also are similar to the families in that each element in a column is there because of its characteristics. So over here, all these elements will behave in a similar way chemically. All these ones will behave in a similar way, for example, in each row. I'm not going to go into detail about the periodic table. I don't really know enough myself, but I do know there's several different ways of classifications in here. So as I said, the families, which are the colours, the rows, which are the rows. And then obviously you've also got the columns, and then you've got the rows. Now the rows, the way it works is that you start with the elements that have the least atomic mass, the least amount of electrons and protons and neutrons, which make up their mass, and it just goes through, they get heavier and heavier and heavier, and that's the order they're put in. And the way that the table is formed is because of these similarities between the different elements, and that's why you get this this structure. So the similarities repeat initially every 8, and then every 18, and then you've got this big chunk here because it's then every 32 as you go further up. But you don't need to know all that detail. Just that this is what I'm going to attempt to make for tangles, and I'm going to have real fun deciding where each tangle goes within this kind of structure. It might not look exactly like this. It's well, it clearly won't, because there's only 118 of these. There's over 170 official tangles, so it's going to be bigger. It might not be this kind of oh well, we'll see how it goes. I've got no idea how it's going to turn out. Just this is the general plan. Also, I'm going to stick with this kind of format on the let's zoom in a little bit, on the bijou tile. So I'm going to have a little 2-letter symbol for my tangle, as well as, I'm not going to have any numbers, but as well as the actual picture of the tangle. So let's have a look at what that should look like. Right, so let's go to bijou, and I'm just going to add just a quick border around here with my pencil, and then so for each tangle we're going to have a little 2-letter code. For example, cubine. Cubine can be Cu, like let's have a look. I think there's Cu on here. Copper, I think, is Cu. See if I can find it. There we go. So that's copper in the elements, and I can use Cu for cubine. And you know, some of these might overlap. This could be Mulligon, for example, and I will choose an appropriate 2-letter code as I go through. And I think what I'm going to do is, I've got to kind of do them in a certain order. I'm going to try and do the tangles in the order of like how complex they are. So let's just grab a pen, and we can start to put some little letters in place for the 2-letter code. So cubine will be a C. So the idea is that, and we're going to do this in the embedded letter style. So we just need a C and a U, and then we're going to aura those. So this isn't an instruction video, but obviously you will see me drawing different bijous each day if you catch the videos. I'm going to try and put a video out for each day. That's my idea. And so we're going to do this we're going to aura these letters, aura them again, add some fescues in Maria's embedded letter style. And then we'll put, I'm not going to today, I'm just showing you this bit. We'll put cubine in the background there on that tile. So let me just chat away to you while I'm doing this with a bit more explanation about why I've chosen to use the periodic table. Well, I've said it's a nice format. It allows me to put things into different categories. So for example, with cubine, it's not just a grid tangle, it's a geometric tangle. It could be classed as a drama tangle, it's a straight line tangle. So it falls into lots of categories. So therefore it can't just have sort of one little spot. So that's why this format's going to be really interesting to play with. But again, why Why is it such a good kind of analogy? Elements and tangles. Well, we'll come to that in a minute, but I think there is quite a good analogy between different tangles and the different elements that exist in the world. So I've done an aura. I'm now adding some little fescues coming off there. They can just go anywhere. 3, I think that's enough. And then we aura again to create our embedded letter look. Around everything. So it's nice to demonstrate this once. I won't necessarily be doing it for all the different tiles. We'll be doing it, but I won't necessarily be demonstrating it because it's basically the same each time. So it's going to give me the chance to really pick apart the different tangles and decide which ones do have characteristics that are like other tangles. Because you might think, oh, well, all straight line tangles, I'm adding a bit of rounding here, must be similar, but when you start to look at straight line tangles, they're all very different, so you might not group them together. So it's going to be a really interesting exploration of the tangles themselves and how they're constructed. I'm just going to go round, adding some rounding in the corners where we've got the pointy corners, add a little bit of ink, an extra bit of ink. And then we'll go around one more time with an aura. And then the lettering will be done and there'll be space for the tangle. And certainly each tangle, well, it will have a unique place in the table, but it won't be set. Unlike with the elements, they are absolutely set in those positions. You know, you can't just decide to put one somewhere else because of the atomic mass, the way they're created, the way the elements form with all the different protons and neutrons and electrons. So they're set, and there aren't any more of them. Obviously, I'm not going to draw all tangles. Can't draw all tangles because there's hundreds and probably thousands of tangles these days published, and more to still to discover. So I am just going to stick to the official tangles. So that's kind of the format we're going to go with in terms of we'll add cubine in the background. I'm not going to do that now. So I just want to talk a little bit about the tangle element analogy. I know Rick loves an analogy, so let's have a look at that a little bit. So all elements are made of, as I said, electrons, protons and neutrons, and all elements are the building blocks of everything around us, yourself, the great outdoors, whatever you're sitting on. Elements make up everything that exists. They are the building blocks of everything, and tangles are the building blocks of our Zentangle drawings. So there is an analogy there. And so if we think of the different bits that go into making up an atom, the electrons, the protons, the neutrons, we've also got, which is nicely called elemental strokes that go up to making up, that come to making up all tangles. So let's have a look at them. There is the straight line, there is the dot, there is the S shape, there is the C shape, and there is the O shape. Okay, so there really aren't any other strokes. Some of them are, sometimes we draw a stroke and we think, well, it's not any of those, but it probably is in one way or another, and we'll unpick a bit of that as we go through. So there aren't in elements, in atoms, there's only certain arrangements of elemental particles that can exist naturally, and that's why there's only a certain amount of naturally occurring elements. However, there's nothing to say that we can't have a tangle that exists entirely of straight lines, entirely of S shapes, and we do. So there's less kind of rigidity there in terms of how we put together a tangle. It doesn't have to have electrons and protons and neutrons as such. It doesn't have to have straight lines and S shapes and C shapes as such. So that's why there's so many more tangles out there, and still more being discovered all the time. So the way we're going to look at our tangles and maybe categorise them is by looking at the pen strokes that we've got, making them up, and just how complicated each tangle is. So the one I've been having a look at them, and I think I've chosen the one I think is least complex of all tangles, and I think it's tossed between one or two, but I believe that therefore is the simplest tangle that there is, and therefore it's just made up of dots. So it's only one pen stroke. It's not even really a stroke, it's just a dot. And we can go into what is a dot and what is not a dot later on. But it's just clusters of 3 dots together, and they are randomly placed. So for me, this has got to be the simplest tangle there is. It doesn't get much simpler than that. So there are 2 things here that are kind of telling us what the tangle is. There's this little motif. So that's just the name for a bit of the pattern that repeats. So the motif here is the 3 dots, and then there's the repeat, which is just random. Just put them wherever you like, doesn't matter what angle they're at. So there's 2 bits there, and there isn't really any other tangle that's like therefore, so it sits quite nicely in my kind of hydrogen position maybe on my table. So it can be the first one. I will be adding colour at a later stage. I'm going to not do any shading so that I can add the colours at the end. So once I've got everything into position and got things where I want them, then I can see the groupings and see where I want to add the different colours. So I won't do any shading until the end really, until I've got all the tangles drawn. So that is the plan. That is the plan. I don't know if there's anything else I need to tell you. I'll be hopefully posting videos each day in the 100-day project, which starts on the 13th of February. Yeah, I think that's it. I guess I will see you then. The journey begins. As I say, creating the tangles in order of tangle complexity rather than any other order. I could have done alphabetical order. I could have done the order in the CZT book of all the tangles. And yeah, we'll go from there and see how it goes. We will see how it goes. I'm looking forward to the journey.